The fuel rail pressure sensor is something you will only find on direct injection engines, be it diesel or gasoline. Direct injection fuel systems don't have a fuel return line, so the pressure inside the fuel rail directly impacts the air-fuel ratio and how efficiently the engine runs. Fortunately for us, this makes it hard to miss the symptoms of a bad fuel rail. The common fuel rail pressure sensor symptoms are black exhaust smoke, poor performance, difficulty starting the engine, misfires, and a check engine light. The less common symptoms are poor fuel economy, stalling, failed smog inspection, and limp mode. 1. Check engine light. A check engine light is fairly common with a bad fuel rail pressure sensor, which isn't the case for a lot of sensors. The reason is that even if the sensor is still within the correct voltage range, the engine control unit, ECU, will note problems with the fuel pressure. For example, if the ECU cranks up the fuel pump but the signal from the pressure sensor remains the same, the ECU will trigger a low fuel pressure fault code P0087. The same goes if the ECU reduces the fuel pump output, but the pressure sensor doesn't report any difference. In that case, you will get a P0088 fault code. Of course, these two fault codes can indicate other faults like fuel leaks, a bad fuel pump, bad injectors, and other faulty sensors. But if the ECU notices faults with the fuel pressure sensor circuit, you will get P0190, P0191, P0192, P0193, or P0194 fault codes. Each of those fault codes indicates a specific fault with the sensor circuit, but whatever the case, you will have to replace the sensor to fix the problem. 2. Difficulty starting the engine. Whenever the engine is cold, and especially when the weather is cold, the engine needs a lot more fuel to start. In other words, it needs a richer air-fuel ratio. The sensors responsible for that are the coolant temperature sensor, O2 sensor, intake air temperature sensor, and in direct injection vehicles, the fuel pressure sensor. If the fuel pressure sensor is faulty and it reports that the fuel pressure is higher than it actually is, the ECU won't signal the fuel pump to build enough fuel pressure to enrich the ratio. The engine then won't start until the air-fuel mixture reaches the O2 sensor in the exhaust, and it reports that the ratio is too lean to the ECU. That results in prolonged cranking before the engine fires up. The delay will definitely be noticeable, and you might even notice that the engine hesitates to start. In extreme conditions, it might even take a few attempts before it fires up. 3. Poor performance. The air-fuel ratio is one of the main things that determines how efficiently an engine runs. The ideal air-fuel ratio varies with different driving conditions, but if the fuel pressure sensor is bad, it will rarely be right. Instead, the ratio will either be too lean or too rich. When the ratio is lean, it means there isn't enough fuel going into the cylinders. That reduces the thermal efficiency significantly and consequently the performance. As for a rich air-fuel ratio, it means the cylinders are getting too much fuel. In such conditions, the spark plugs have a hard time igniting the fuel as there isn't enough oxygen, and the fuel isn't atomized properly. That in turn causes the mixture to ignite too late, essentially retarding the ignition timing, which directly reduces performance. At the same time, a lot of the fuel goes out of the exhaust unburnt, which also hurts the performance. 4. Black exhaust smoke. Black exhaust smoke is one of the most obvious symptoms you will notice when the fuel pressure sensor goes bad, but it's only noticeable in diesel engine vehicles. Diesel fuel is a lot more greasy and naturally makes more smoke, and when the air-fuel ratio becomes too rich, a lot of that unburnt diesel is converted into thick black smoke. Black smoke can also happen with gasoline engines, but the smoke will barely be noticeable even in extreme cases. It's important to mention that black smoke as the only symptom can also be caused by other faulty components and sensors. Some of those include the O2 sensor, MAF sensor, coolant temperature sensor, a bad fuel pump, and even a clogged air filter. Virtually anything that causes a rich air-fuel ratio. That's why scanning the fault codes is crucial before you go out and buy a new sensor. 5. Failed smog inspection. If you have an annual smog inspection coming up, doing it before replacing the fuel pressure sensor is a bad idea. The rich air-fuel ratio caused by a bad fuel pressure sensor will double or triple the exhaust emissions, a fact made obvious by the black smoke in diesel engines. All that smoke is basically soot and diesel particles that the DPF can't contain because of the sheer volume of them. A lean air-fuel ratio will also increase exhaust emissions since the fuel doesn't have enough time to burn off. That increases nitrogen oxides and carbon dioxide emissions. 6. Frequent misfires. Whenever the air or fuel ratio is incorrect, the chances of misfires increase drastically. When the air-fuel ratio is too lean, the fuel burns slower. That means the fuel could still be burning when the exhaust valve opens. Exhaust backfires are a direct result of that, and backfires are recorded as misfires by the ECU. As for a rich air-fuel ratio, there is a chance that the fuel won't ignite at all because there is not enough oxygen to create combustion. That can trigger a random misfire fault code, P0300, or one or more of the specific cylinder misfire fault codes, P0301 to P0312, keep in mind that misfires can be caused by every other sensor and component. Those include the spark plugs, ignition coils, spark plug leads, the crankshaft position sensor, and the camshaft position sensor. 7. Stalling. Stalling is another fairly common symptom of a bad fuel pressure sensor. As the fuel pressure sensor directly interferes with the fuel pressure, it can cause it to drop too low or increase too much. When the fuel pressure drops, the idle speed will briefly surge before it drops down and the engine stalls. That's a result of a severely lean air-fuel ratio. When the fuel pressure increases too much, the ratio becomes too rich. That causes the idle speed to die down before the engine slowly stalls. While that's happening, the engine will seem to be misfiring and shaking. Stalling can happen right after you start the engine on a cold morning, when you stop at a red light, and in extreme cases, when you shift gears. 8. Limp mode. Limp mode is a special condition that's triggered when the ECU notices a fault that can cause major damage to the engine, but the engine still runs. Limp mode is made to minimize the chances of damage while allowing you to keep driving to the nearest repair shop. What limp mode does is it limits the power output, RPMs, top speed, and certain gears, and sometimes it shuts down some driver aids and the AC. When limp mode is on, you will also see different warning messages depending on your car and possibly a check engine light. Limp mode triggers because of a bad fuel pressure sensor when the ECU notices the fuel pressure isn't where it should be given the fuel pump output. The ECU doesn't know what the problem is, and it assumes the worst possible conditions. Those conditions are a severely lean air-fuel ratio. A lean air-fuel ratio can increase the combustion chamber temperatures to the point where it melts the pistons and destroys the cylinder walls, the turbocharger, the catalytic converter, and a lot of other components. The potential damage is then definitely worth triggering limp mode. 9. Poor fuel economy. With every issue that negatively impacts the engine's thermal efficiency, the fuel economy also suffers. To what extent the fuel consumption will increase depends on the severity of the fault. In the case of a faulty fuel pressure sensor, it can range anywhere between 5% and 30%. Both rich and lean air-fuel ratios will significantly increase fuel consumption. And as we mentioned, both conditions can be caused by a bad fuel pressure sensor. A lean air-fuel mixture should at first glance decrease fuel consumption since less fuel is going into the combustion chamber. But that also means that the explosion will happen too late, which results in a lot of that fuel being turned into heat. At the same time, the engine performance reduces drastically, so you will have to rev the engine higher and open the throttle more. Both of those conditions will further increase consumption. A rich air-fuel ratio directly wastes fuel, since all that extra fuel comes out of the exhaust unburnt. Fuel rail pressure sensor replacement cost. The cost of replacing a fuel rail pressure sensor largely depends on the type of car you drive. A new sensor will set you back between $50 and over $350 depending on the make and model, plus the production year. But the average price is right around $100. And those are replacement sensors. OEM sensors will cost between 20% and 50% more. Going for the OEM sensor is a good idea, but these sensors rarely fail, so you are pretty safe with a high-quality replacement. As for labor, it again varies a lot depending on how difficult the sensor is to access. In some cars, the sensor is right there, and it only takes 10 to 15 minutes to replace. But on others, the sensor might be buried under a lot of other components, in which case the job can take over an hour. That puts the labor cost range at between $50 and $150, with the average cost being around $100. That makes the total cost for a fuel rail pressure sensor replacement with parts and labor $200 on average. How to replace a fuel rail pressure sensor. The fuel rail sits right on the side of the cylinder head above the injectors, and the fuel pressure sensor is somewhere on the fuel rail. That can be in the middle, on one of the ends, or on the side. The pressure sensor is the only one on the fuel rail, so it's easy to recognize. It also helps to Google the exact location of your specific vehicle to see what you will have to remove to get access. In most cases, that's the plastic engine cover, possibly the intake boot, and in extreme cases, the intake manifold. However, manufacturers usually leave enough room to reach the sensor without removing the intake manifold. Inspect the sensor connector and find the locking tab. Then push the sensor in and then release the tab before pulling the connector out. Now it's time to remove the sensor, but keep in mind that some fuel might come out of the fuel rail. It's a good idea to put some old rags around and under the sensor because you could create a fire hazard. The sensor is held in place with 2 or 3 bolts that are very easy to remove. Once the old one is out, installing the new one is just a reverse procedure of removal. To summarize what we talked about in this video, the symptoms of a bad fuel rail pressure sensor are inconclusive when it comes to diagnosis. diagnosing it. A dozen other components and faulty sensors will cause the same symptoms like black smoke, poor fuel economy, poor performance, and so on. The only way you can know for sure that it's the fuel pressure sensor causing all the symptoms is if you get the P0190 to P0194 fault codes. Other than that, have the sensor tested by a professional. I hope this video helped. Thank you for watching. Don't forget to like and follow so you don't miss any of my videos.